This conference will now be recorded.
All right, great. So welcome to the ESTEP and USGS Community for Data Integration, Interoperability, and Technology Working Group webinar. Really happy to have Chris Gorgolewski, I think that was right, on the pronunciation, with us today from the Google Dataset Search team. He's going to give us a presentation on what they're up to, and my understanding is he's going to leave a good amount of time at the end for discussion. So really looking forward to this talk. I don't have anything lined up for next month, but I'll be in touch about that. That'll be overlapping with the ESIP summer meeting. So there's a chance that we will forgo next month, but stay tuned, we'll see. So without further ado, I'll turn it over to you, Chris. So go ahead, take it away.
Okay, thank you for the invitation. As you mentioned, I would love this to be as interactive as possible. I've got some slides and I walk you through the general concepts, but please don't hesitate to ask questions. This is really for you, and you can drive the discussion here. Okay, so my name is Chris. I recently joined Google to work on Dataset Search team, and some of you might not be familiar with the product because it launched very recently, last year. So what is it? Well, basically, it is a search engine for datasets. So the same way as you would use normal main Google search to search for general websites, you would use Google Flights for search for airline connections. You would use Google Jobs to search for new employment opportunities. You can use Google Dataset Search to look for datasets. And this is a product that has already launched. Some of you might be curious why we even pursued this idea. Well, the landscape of data publishing is quite diverse. If you look at websites that aggregate metadata about data repositories, you would see hundreds, if not thousands, of registered repositories, for example, on Free Data or on Fair Sharing. So there's a plethora of different places where scientists, researchers deposit data. There should be a lot of different repositories because different scientific communities have different needs. And it's very difficult to provide accurate data curation and data description in a generic way. You have to have expert field knowledge to do this, and that's why different communities will have different repositories. So generic entities like Nature Scientific Data would recommend many different repositories because each of them serve different purposes. DataSide, which is an entity that registers DOIs for datasets, counts around 1,700 different data centers, as in the entities associated with the DOIs. We have also commercial data providers such as DataWorld or Kaggle. As you can see, there's plenty of them, and that diversity is healthy. But it's difficult to navigate. If you are looking for a particular data set, if you're looking for data set with certain properties, it's hard to figure out where to start, where to begin your search. And this is why dataset search happened, because if you use the main search, you might be taken to websites that describe certain facts about the world, for example, Wikipedia pages and things like that, rather than datasets themselves. So we want to focus on that. So we built this search engine. And to be more precise, it is a search engine, but it's a search engine that doesn't actually search into the dataset themselves, at least not for now. It searches over metadata of datasets. So in other words, we are indexing what data repositories tell us about the datasets they host. And that sort of contract makes it easier because it's less actual bytes for us to go through. And it gives control to the data providers over the narrative, over what properties of a given data set should be advertised. In other words, we leave it to the field experts to tell us what are the relevant variables in the data set, or to tell us when the data set was created and what's the most accurate description of the data set, instead of us trying to infer those pieces of metadata from raw unstructured HTML for every single scientific field out there. So this is one of the versions of the search results. The live one looks a little bit different now, but the general gist is that for a given query, here you have Earth Engine, you're gonna have a list of results on the left and details about a particularly selected result on the right. And those details actually correspond to metadata aggregated from data providers. For example, there's a dataset name, which is a field that we have obtained from a data provider. The same goes for a description of the dataset, and then the entity that provided the dataset, as well as things like temporal, spatial coverage of a particular dataset, if that is relevant. And all these fields we obtain from the landing pages of those datasets. Those landing pages, to be indexed by Dataset Search, need to adhere to a standard called schema.org. And this is an open, community-driven standard for different entities, including datasets. And practically how it's embedded into the website, there are multiple different ways to do this. The most common one is basically a JSON LD snippet into the HTML of the website. I can show you later how something like that looks like in practice if you're interested. We also provide tools for webmasters to verify whether the metadata embedded in those landing pages are being picked up and parsed correctly. We also provide integration with Search Console, which is a product that allows webmasters to monitor how well their websites are being crawled by Google. And that Search Console will tell you, for example, if there are any detected errors in the structured metadata of your websites, or what's the coverage of the sitemaps you have submitted. So this is basically how we obtain this information. And we decided to go down the open route of schema.org because we want this to be a project for the community. We want to index as many datasets as possible. So we want it to be something that the community will have a say in. And that's why we're using this open standard. And there's a GitHub community around schema.org where people discuss different extensions to this standard. And we gradually, when something becomes more and more common, we pick them up and try to make use of them in terms of presenting the results or indexing the data sets. And this is driven by adoption in real research products or real data sets. We constantly look how certain slightly underdefined schema.org fields are used in practice, and we try to reconciliate differences in interpretation. And it's also open in a way that other search engines also can pick up the same syntax and build different search solutions for the same purpose. And it is pretty straightforward to add to your website. In my previous life, I've been running data repositories, so I've implemented this myself, and it is pretty straightforward and gives very quickly an additional exposure to your data. And speaking of that process, the thing that we really care about to be successful in our mission to provide service to the scientific community is coverage. Because on a big level, what we really want to do is to make data findable. And if we don't have good coverage of data sets out there, we're failing in that mission. So we are providing developer documentation and support for data providers, helping them getting their repositories indexed and accurately represented in dataset search results. And basically, this boils down to three main things. One of them is checking whether the website you are providing does have schema.org, and whether the schema.org validates using Google Structured Data Testing tool, which is this tool I've mentioned, that will fetch your website the same way Google will fetch it, and parse the schema.org metadata inside it, independently of what format is it presented in, and show you how does it look from the eyes of Google crawler. And then there's also a question of finding all these websites. One of the reasons why dataset search is an important sort of deeper dive into a small sector is because many of these websites are not linked from blog posts and the New York Times, and those are not the landing pages for many datasets are not what in context of normal search ranking you would consider highly popular content, because it is relevant to a small community of people who are doing very important work, and that's why letting us know explicitly about the existence of all of the different dataset landing pages might be the best way for you to get the exposure. And that is provided through sitemaps. So sitemaps are structured, formalized XML documents that list all of the different websites in your pages in your website. And there you can list all of the different landing pages for all of the different datasets. And we would crawl the pages on those lists to make sure that all of them will show up in the index. And we have a dedicated process to do this, and we really care about coverage for datasets. So if something doesn't work, get in touch. And then finally, Google Search Console is a great feedback tool. I've been using it for data reports I've run before joining, and it's super useful for many things, including how people find your website, but also to figure out what's the coverage. So, for example, the percentage of the pages that you submitted via your sitemap, what's the percentage of these pages that actually have been crawled and indexed by Dataset Search. So this is very useful. I recommend using that tool, and this will help you expose your data. So you might be also wondering what we're doing inside the machine, and how does this whole crawl process and indexing works. And I can talk about this a little bit. First of all, we're dealing with a few thousands of domains or of the data providers, and that amounts to I think we have 15 million data sets right now. So there's a lot of data to crunch, and what we are doing, we are cleaning up the metadata. So we are trying to extract as much useful metadata that we are given. Of course, the more you adhere to the recommendations, the better. But obviously, we're not going to throw away everything that is slightly off. So there's a lot of data cleaning and robust data metadata extraction. There's also reconciliation with knowledge graph, where we're trying to figure out best way to link this data set to particular entities, such as data provider, as well as locations. So those would be geographical places. And then this is something that we work a bit more right now, and hopefully the effects of that will be seen. We are linking to scholarly papers, and we are trying to find links between papers and datasets, because it's very important not only to understand the different uses of a dataset and be inspired, and not to do work that others have done already. That is allowed by seeing what other papers use this data set, but also it's important within the incentive structure that is the driving force in academia. So all of that ends up in the catalog, and this is what you will see when you type a query in Google Dataset Search. So in other words, we have a crawler. We extract all of the metadata. We do cleaning, reconciliation with the knowledge graph, and then we do a bunch of deduplication and replica identification. A lot of entries we are getting are from aggregators. So those are entities such as data.gov. For example, that aggregate metadata about datasets from many different sources. And those are great sources for us, but while we increase the coverage, we get closer to the actual original source of metadata, and then we have to make sure that this entry we found on this aggregator webpage and this entry that we found on this other webpage is actually corresponds to the same data set, and then we have to figure out which of these entries is actually the primary source. So we're doing a lot of work on that, and then linking with papers, finding citations in papers, and all of that gets deposited in sort of the corpus. You type a query, and then we give you back ranked results. So this is more or less how it works. And if you go to g.co dataset search, you can find the product, and I would love to hear what you think about it. And there's a feedback button in the upper right corner. Don't hesitate to press it and tell us if something doesn't work. Yeah, seriously, please do, because very few people talk to us, and we feel very lonely. So would really appreciate your feedback. We are in beta, and that means that things can change, and this is also the time to influence the product with your feedback, and that's why we crave it so much. And finally, we see ourselves as a member of this larger community of people and entities that are passionate about data publishing, and that means providing metadata using community standards for this pieces of metadata, but also data consumers that need to cite data properly. Excuse me. To give proper scientific credit to data producers and developers who take advantage of different open standards and APIs to build tools that allow people to explore this ocean of data. And I think that what I'm most personally excited about is the circle of publishing and citing, and I hope that we can be part of a positive change in the publishing ecosystem by providing better information about how different data sets are being cited and what is the impact of a researcher that decided to share a data set and this data set has been reused by other people in the field to provide more knowledge without having to acquire, sometimes in a very expensive process, new data. So, as I said, this brief introduction, but I would like to open the session to questions, and I would love to hear more what you think and whether you have any particular questions. And encourage you to check out the product. Hopefully, it doesn't require much more introduction.
Excellent. Thank you for the great introduction. And yeah, we've got plenty of time for questions. So I put everybody on mute before we started, but you should have control to unmute yourself and fire away.
Hi, Chris. My name is Emily Reed from the U.S. Geological Survey. Can you hear me all right?
Yeah. Hi.
Hi there. So thanks for the presentation. I've got a question for you about how results are ranked in the Google Dataset Search. And I have to say that I don't, I only have a little bit of knowledge of the way that Google, just google.com ranks results. I know a little bit about that, not a lot, but I would think that for data, there might be different considerations. So could you say a little bit about how the ranking is done on data sets?
Yeah, sure. So there's the part of the technologies we use are from main search, and there's a lot of signals for every entry that we use to figure out whether this result is relevant to your query or not. Many of them come from the main search, so that goes back to PageRank and to number of ingoing and outgoing links. But we also use the information provided in the metadata, including some of the information that we are not showing on the dataset description. So we try to use all of these signals to give you relevant results. So this is the full algorithm of figuring out what will happen. So what result will be shown on what place is very, very complex. And right now we're using mostly off-the-shelf stuff that has been used for similar products, but we are looking into some ranking issues that might be specific to datasets. Right now, the rankings have been, we think they provide a relatively good experience for specific queries. Generic queries are harder because it's much harder to figure out, like if you type weather, what did you really mean, and like what sort of data about weather are you interested in? The weather since the beginning of time for the whole world or specific region. But if you come across a query where results you think are not good and certain things should be reordered, just click that feedback button and let us know.
Okay, thanks. Yeah, I'm just thinking about specifically the way that when I'm looking for data, the ways that I might narrow it, using some kind of some kind of an interface or portal. In this case, it's just free text, I suppose, that you would enter. So I guess I want to play around with it a little bit to see how that would work. But thanks for answering the question.
Yeah, okay, I see a bit more. So we support the search operators that are in main search. So for example, you can limit it to a certain domain, or you can exclude a certain domain. For example, let's say you don't want to see results from a particular provider because you know that this particular provider requires you to sign some agreement before seeing data, and you don't want to do it. So you can exclude those. And we are considering adding more specific search operators. So those are basically specific keywords with values that you can put into the search box, or potentially a graphical UI for the same functionality that would allow you to get more control over the results. But I would encourage you to try to perform your query in a natural language and see whether this actually gives you the results you want, or whether there is an actual need for narrowing it down. That's good feedback.
That's an interesting question, because I was actually playing around with it myself, with some very general terms like Fish Creek. And yeah, you get things from Australia, but as soon as you put in a place name that's even remotely close to what you're looking for, it does narrow down to much more relevant data. So it's a different, I think it's the way that most people actually interact with search, but it's a different way than people have typically searched for data sets. So it's interesting.
I have a couple of questions. This is Doug Newman from NASA Earth Data. A couple of questions about transitions. So the first place people generally will look for a search is Google search. And I noticed that if you start typing job-like terms into Google search, one of the results will be like, have you tried Google Jobs? I was wondering if you had any plan to do the same thing for Google Dataset Search. If I started typing Modis into Google search, one of the results would be, hey, I think you really need Google's Dataset Search for this. Is that in your plan?
It's a great feedback. Unfortunately, I cannot comment about upcoming features as a company.
All right, well, forward that request to anybody you see fit then.
I will. It's great feedback.
So the second question is the transition on the other half of that. And you're probably going to give me the same answer, but I want to plant this seed as well. Generally, when you get to a data set landing page, it's, well, what do I do now? You've got somewhere, but you haven't got exactly where you want to be. And we've started, NASA Earth Data has started embedding, as well as the schema.org tags that you guys are leveraging for resolving searches to our collection landing pages. We've been putting search action elements into our landing pages, which basically are kind of what we're calling a smart handoff from that landing page into our discovery tool, Earth Data Search. And within that search action, we describe Earth Data Search's API and say, well, you know, if you want to specify a spatial constraint, here's how you do it. If you want to specify a temp constraint. And it strikes me that as one of the previous members of this call mentioned, if you start putting natural language constraints in, like July 2016 or summer 2016, or spatial constraints like Beijing, that Google is really good at figuring that out. It's their stock in trade. And they can transfer that context into another more bespoke tool like Earth Data Search. So that's another kind of bug in your ear I want to put in, that we can enhance that transition from Google Dataset Search into NASA's discovery tool or NOAA's discovery tool or other organizations in a much more seamless, user-friendly way, rather than me getting to that data set landing page after I put things like Beijing summer 2016 into Google Dataset Search, and rather than having to build up that context again in a data search once you've got there, that it would all automatically be done. And schema.org has that infrastructure to achieve that.
Okay, so thank you. This is great feedback, and I think that you can already achieve this with the existing infrastructure. So all incoming links will have, incoming traffic will have referral information. So you know which place you've been linked to. And that referral information in context of dataset search will have the search query. So you can already modify your systems to extract whenever you recognize that this person came from dataset search, you can extract the search query and use it in whatever way you want.
That's an idea I hadn't contemplated. Yeah, I see what you're saying.
So you can do that. But I want to follow up on this, on the second thing. It's an interesting thing. I haven't thought about using the like, I know that the search elements are good for like very generic queries. Like if I Google Pinterest, I'll get a search box inside the results to narrow down, okay, Pinterest, but what I'm looking for. But I would like to understand a bit more that use case when I'm looking for a data set. I have some specific query. I find a data set. I go to the landing page of the data set, and if this is not the data set I'm looking for, then we have a different problem. Maybe we're not ranking your data correctly. Maybe we're not representing it correctly. Maybe you're not giving us all of the metadata.
No, it is. The use case is it is the data set you're looking for, but there's a whole another step in that acquisition of data problem. There's a level below data. Yeah.
Okay, I see. So
you're solving that part of the problem for us, and then you need to hand that off to that organization to solve the next part of the problem. And that's the area I'm interested in exploiting.
And but you can even like use it. Yeah, sorry, carry on.
Sorry, go on. Well, I was going to say I have to love you and leave you because I have to go to another meeting now. But I wanted to plant that seed in your head, and I assume I can. I'm in contact with Natasha Noy in your group, so I can get to you through her, I assume.
Yes. Natasha will forward that to me. Look at the referrals.
Right,
I think. All right. Take care.
Yeah, I will. But I'll be in touch. Thanks, everyone. Bye.
Great, good conversation. Any other questions? I've got a few of my own if there aren't any others, but I'll leave the floor open here. Okay, well, I guess one thing I find interesting about these kinds of search results is this level of granularity problem. A lot of the data sets, quote unquote, that I'm able to find are coming from data.gov type catalogs, whether they're state level or federal level. And many of those data sets are, something that was created by a project that's local, but some of them are records that represent entire collections that are a national data system. Thinking, data.gov has one record for the stream flow that USGS offers, which was a decision to not add 10,000 stream gauge locations to data.gov. And we didn't really have a happy medium available to us readily, other than maybe going state by state, which wasn't real satisfying. And we're working toward this ability to have catalogs of, for lack of better words, feature level exposure of our web resources, where an individual site or an individual granule maybe is available as a web resource. And I'm wondering if you all have started engineering your way around, well, that granule that may be of interest to somebody on the ground is part of that other data set that has one DOI and one big record in a data catalog. And if has that started to appear, or are you still kind of at the, well, there's this domain and it has a bunch of this domain or this catalog and it has a bunch of data sets, and that's kind of the end of the story?
Yes, it has appeared. With 50 million data sets, you start seeing all sorts of stuff you haven't expected. So we have all sorts of levels of granularity, starting from, as you said, like this general entry for a repository. Like, it's not even a data set, it's like a collection of data sets, to snippets of data that are super tiny. That are, like a JSON file with single entry. Sorry, can you still hear me?
Yeah, we can.
All right, sorry, the static went away, and okay. Anyway, so yes, lots of different levels of granularity, and my sort of envisaged solution for this is we can only work with what you give us. So if you present us with different levels of granularity, we can then try to figure out from that information which level is relevant to a particular search query. So for more generic search queries, we're going to show higher level of granularity. And for more specific things, if you don't tell us about these specific things, we won't be able to give that specific result. And right now we're not using this information, but there is a schema.org vocabulary to show a more fine-grained relationship between data sets. So right now we're using this to say that a particular data set is a copy of another data set or is derived from another data set. But you could also envisage using, and this vocabulary exists in schema.org, to say that this is a subset of another data set. And that will help us potentially in the future to navigate this field of granularity and make sure that the results we're presenting are matching in terms of granularity the intended granularity in the query. Does this answer your question, or did I diverge?
No, that's spot on, and I'm envisioning some solutions already, and I see where you're going with that. Is getting some commonality to practice of declaring collections is going to be really, and maybe not even commonality, but getting something that you all can find as a pattern in the crawled results. And using schema.org collections is a clear path there. It might be something that actually goes to kind of another question, and that's that there's a new standard for spatial feature exposure on the web. That's WFS 3 is the web feature service version 3. That's a complete reimagining of the WFS, and it's intended to be much more quote unquote webby, in that the default response is always HTML, and JSON and GeoJSON are the default machine readable formats. And they've introduced this idea that a WFS is a collection of feature collections, and each feature is a member of n collections. And I think that would map onto what you guys are doing really well, because the feature collection is kind of a data set. The WFS is kind of a server worth of data. It's a domain, it's a single domain. And then down at the feature level, you have a whole richness of attributes and a potential to attach all kinds of metadata. So anyways, I think that's going to be, as we see more WFSs roll out, I think that's going to be a rich source of crawlable information for you all, because the idea is that the collection level is essentially hypermedia that gives you pageable access to all of the actual features in the collection. So I'm wondering, the question is essentially, I'm wondering if you guys are tracking with that work, and if you like how, if you're not, are you aware of it and providing feedback? Because it seems like something that if you provided a little bit of feedback to those kinds of best practices and standards groups, there'd be a potential groundswell of people that would follow suit.
Yeah, so first of all, thank you for bringing this up. I was not aware of this initiative, which sort of answered the question. I don't know if other members of the team were. As a more general answer to involvement in community standards, with the with great power come great responsibility and all that. We're trying to individual community. For example, I'm a neuroscientist and computer scientist by training, so I'm probably not an expert in nerve sciences. So I might not be the best person to weigh in. So I feel that it should be a bottom-up process when individual communities figure out what's the best standard way of describing their data. But it needs to percolate towards some sort of a container, and that could be schema.org, and this is what we are indexing right now. So what I would practically recommend is to try to see whether you can link or somehow embed all of the work that has been done for WFS 3.0 into an extension to schema.org. Because standardization, the hardest part of building any standards is defining different terms and figuring out what terms are important and what this field means and what are the different allowed values in that field. And that's like 90% of the work. And then whether it's represented as JSON or something else, that's less important. So I think with the work you've already done with WFS, it might be easier to introduce those features into schema.org. And then that will also mean that it will be easier for us to crawl them and use them in search results in the future.
Yeah, no, that makes sense. And it's largely the WFS3 movement is really part of, from my view, it's part of this collaboration between kind of the spatial data, Open Geospatial Consortium world, and the W3C data on the web, and now spatial data on the web group. So it's kind of that space. But I hear you that it definitely needs to be a bottom up kind of semantics and data representation process, and you all will work with what gets come up with. And yeah, good. Okay. Well, are there any other questions on the line? I see Rick Brown is unmuted, maybe, or anybody else?
Yeah, this is Byron. I've got a question of kind of related to schema.org, and I guess the last conversation is other formats that might be crawlable. Do you support like DCAT and looking into that at all?
Yes, we do support DCAT.
Good.
Yeah, so we do support DCAT, and we do support one more format, which is more sort of like an inline format. I believe it's called microdata or something like that. I am blanking on the name. Let me just quickly look it up.
So would that include RDFA as well?
Yes.
Okay.
And there should be examples of RDFA on the developer doc that I just linked in the forum.
Right. Anything else? I have one more topic I was ready to bring up, but if there's any other questions on the line, I'll.
That's okay, go ahead. I had a quick question about, I think in an ideal world that Google would actually write a discovery tool that uses WFS3. But, you know, like David said, I understand that that might be impossible to do. But I guess my question was kind of along the lines of the RDFA. Do you have any semantic web extensions that, or you know, speaking of having custom discovery code, do you have any code that takes in semantic web notions such as, you know, water temperature, you know, that has a meaning, same meaning across different sources and things like that?
Yeah, great question. So just to address the first aspect, so there are some fantastic standardization efforts in many different fields, and they should be really bottom up. But there are many different fields, and each of them will have different standards that fit their own needs. And we're trying to be good and be useful for all of these different fields, and that's why we sort of have to work on a slightly more abstract level, and we have limited engineering resources as well, so that's why we are focusing on schema.org. But as I said, the hardest thing is to define those fields, and then it's easier to translate that work into schema.org, and then it will percolate to us. And then to address your question about parsing semantic web entities. So to the extent that we parse JSON-LD and parse RDFA, that is true. In terms of following up different links that are present in those entities, that is done partially, but not fully. And right now, I don't know off the top of my head what exactly we are following and which things are not reconciled. Yeah. So that's,
if you look at, there's a project called the Marine Metadata Interoperability Project. I'm not sure if that thing's still alive or not, but they had such a way, and I think that was based in San Diego, so I'm not sure if I got the right one, but they basically do that. You know, they bridge, you can take a variable and it'll bridge you into different subsystems, essentially, based on that. So anyway, that would be a great feature. I guess that's all I had. David, you can go ahead.
No, thanks. And that's, I mean, at a certain level, the magic box that is the Google Index is doing much of that for us, just not in a way that we see, and not in a way that very many people probably understand, which is fine because it seems to work. But what I wanted to ask, the last topic I wanted to bring up is actually somewhat related to that, and it has to do with inference about spatial, so not just spatial regions, but entities. And in particular, I'm wondering if there's been any specific work on observation. So the associations between data that's been observed and the thing that was observed is kind of a special type of relationship, and many times that's the people are making searches for observations about a particular place or a particular thing. And I'm just wondering if that's come across your radar, or if you can comment on that at all, because that's definitely something a lot of the earth science folks are very intimately related with, is taking observational data archiving it, associating it with what was observed, and then trying to make it available to people that are interested in the properties of those things that were observed.
Yeah, this is great feedback. I know we're doing some work in terms of what variables were measured, and this is already exposed. But in terms of what is the entity that was measured, for example, in biological sciences, you might want to have data sets studying macaques or pigeons. So I don't think we're doing much work on that front, but I think that would be very interesting future endeavor potentially.
Okay, that's good to know. This is something that, at a certain level, we need to know if we expose this information, will it get used? And we certainly will be exposing that information for some of our systems. You know, we maintain a system that has the river network in it, and we want to be able to crawl data sets that are observations of rivers and index them to the river network, and then help people discover where observations are along rivers, which is a bit more boutique. And I'm hopeful that once we get that system up and running, and your crawlers and the machine learning behind the system can work with it, that a lot of that will be available to you in the dataset search world, and can be enriched with all the additional kind of sophistication that's in Google. But we'll have to see. Let's look back in 5 years and see how it went.
So one way of sort of implementing that right now is because you know the standards and you know the different links that are relevant in your field the best. So if you have an entity, if you have a data set that is relevant to earth sciences, and you also know what is it describing in terms of, you have this permanent URL for the entity that it is describing, and maybe you have other links there. If you can resolve those links into a human readable description on your side and embed that into the description of the data set that you provide to us, I think that would take us 80% of the way in terms of discoverability. Because then we would index that, and for example, you would say this data set describes observation of type A of the object B, which is also known as C and D. And if you say that, and then someone says, give me observations A of D, we'll find it.
The irony is it would be in human readable form, but no human would ever want to read all that content.
Yeah, so there are different ways to like phrase it, but that's like with existing state of the infrastructure, I think that would work. And and again, like when I was building descriptions of data sets for my repository, I started embedding metadata there because that was giving a more relevant search results there. And that's, I knew how these pieces of metadata are represented in my particular data store, and I was just exposing them in a more natural language way. And that, it's not perfect. We don't do like reconciliation across languages, for example, different languages. But I think that it's a low-cost thing that you can already do right now that would give you big benefits.
That's interesting. So if we come up with a RDF or JSON-LD serialization of our domain data models, you're saying it would be worthwhile to resolve those associations into spoken language, so that the search infrastructure has a natural language set of associations to interpret and build into the index.
Yeah.
I like it. Yeah. That's a fascinating concept. I really like that idea, actually.
And when you think about it, that spoken language, that natural language is the biggest target for search engines, because humans use it all the time. Right. Many more humans use natural language than semantic web links. So there will always be better like technological support of that or maybe not better. This is not the right word here. I think it's going to be more. There will be better coverage, as in more entities will invest into natural language.
Oh yeah, no, they go hand in hand. And if you can, I'm imagining what were the books? The Design Your Own Story, Choose Your Own Story books. You choose your own story through the semantic web linkages. I think that's there's an analogy there. Anyways, and we were right toward the end of the hour here. Any other final questions?
Yeah, I have a quick one. Yeah, I really like the way that this is presented. The natural language presentation of the results and such is really nice, but particularly like how it links back to the sources where the data was found for you to find out more information. That is your primary link. It makes this really useful in most of the contexts I work. One suggestion that would be nice to have on this is if when you mouse over, like this one I'm glancing at says, explore a catalog.data.gov, something that explains some brief snippet about metadata about that catalog, or that source. So the problem is that if I'm trying to solve is that may have a half dozen of these and a quick kind of pointer to things like, oh, well, this will be the more authoritarian source of what I'm looking for than that. Would be kind of nice just to have something, a little more information about those linkages.
I hope you hear me typing because I'm writing this down. This is great feedback.
Good. Thank you.
Yeah, thank you so much. This was really helpful, and I greatly appreciate the conversation and taking time for us. I'll definitely be in touch about some other ongoing projects that are highly related. So
thank you for having me, and yes, if you come up with other ideas, feedback, or you see something completely broken, just hit that feedback button in the upper right corner and let us know.
Great. All right, thank you so much, and we'll be in touch with the ESIP and CDI community. Thanks for coming along, and we'll be seeing you.
All right, bye-bye.
Bye-bye.
Thank you.
Thanks.